Hey geometry students, let's go ahead and review for the test that you'll be taking for me next week. In this week's work packet, you should have received that review list and you can go ahead and take your notes right on there. The last review list that I gave you, some of you turned that back in with your packet. I do not need the review list back. That is for you to keep. That's for you to study from as you're preparing for the test. So on the review list, as well as on the screen, you see it's test 12, and it's going to cover from lessons 84 and also 86 through 89. And we have a total of 25 questions that we'll be answering. I'll cover the first half of the review today, and we'll do the first half during our next time in class. The first thing that you'll be facing on your test came from lesson 84, where we talked about dilations. Remember, dilations made things either bigger or they made things smaller. What I'm going to have you do on the test, very similar to what we did during class. I'm going to give you a few different ordered pairs. So let's say I gave you 3 different ordered pairs, then I'm going to tell you the scale factor. Well, the scale factor is the ratio that's being applied to each one of our points. Remember the notation that we use for a dilation, it was capital D, which meant a dilation, then the letter O, because it was centered at the origin, and there's my scale factor of 1/2. The 1/2 applies to each one of the points, so I picked the point 4, 6 to begin with. I took half of each one of those numbers, so half of 4 was 2, and half of 6 gave me 3. I would then proceed to do the exact same thing with the other 2 points. So the dilation centered at the origin of the scale factor of 1/2, our second point was 6, 2. Half of 6 was 3, and half of 2 is 1, and we'll do the same thing for the last point. The dilation centered at the origin if the scale factor is 1/2 and the point is 2, 4. Half of 2 is 1 and half of 4 is 2. Your final answer would be those 3 ordered pairs that you would have on the right-hand side after you correctly apply the dilation. You'll have 2 questions like this, so here's what the other one would look like. So one of the questions, the scale factor will be a fraction like we just did. This one, the scale factor is a whole number, but it's the exact same process. The dilation centered at the origin if the scale factor is 3. Well, the first point I have is 4, 4. So multiply both of those numbers by 3. So 4 times 3 gave me 12 inside both of the numbers in the parenthesis. The second one, the dilation centered at the origin if the scale factor was 3 and our point was 6, 4. So 6 times 3 was 18 and 4 times 3 was 12. And the dilation centered at the origin if the scale factor is 3, the last point was 6, 2, so 3 times 6 was 18, and 3 times 2 gave us 6. Again, the correct final answer would be those 3 ordered pairs off to the right-hand side that have the dilation applied to them. The next thing that you'll be facing out of questions 3 through 5 came from lesson 86, where we talked about intersecting chords. Remember, intersecting chords were the lines that ran into each other on the inside of the circle, and we noted there was a relationship between the lengths of the different chords that you have. The first 2 questions that you will face in this section look like the following, where we have 3 different numbers and you're missing one of the numbers when it came to the chord length. Now remember, to solve these questions from lesson 86, the property that we had looked at was the product of the chords were congruent. Remember, we had to multiply the pieces from the same chords together. I always like to start with the part that has the X first. Well, what's the other section of the chord where the X was contained? Well, here's my letter X. If I continue along that chord, I run into the number 9. So the 9 and X are the pieces that get multiplied together, and the same thing for the second chord. The 6 is one of those lengths, the 6 is the second length, those 2 get multiplied together. So 9X equals 6 times 6. 6 times 6 gave us 36, and to finish getting X by itself, I would divide by 9, and that would tell me that X is equal to 4. Remember, we said that the 4 different lengths weren't necessarily equal, so please don't think, oh, that one chord was split into 6 and 6, therefore the other chord has to be split into equal pieces as well, because you're going to end up getting the questions wrong if you do that. So make sure that you set it up as the product from the same chord is equal to the product from the other chord that you have in the question. The third problem that you're going to face in this section requires a little bit more solving with the arithmetic steps to solve for the X. So let's review how to do this picture. It's the same process. I'm going to multiply together the pieces from the same chord, and those are equal to the product of the pieces from the second chord. Well, the first chord that I used was the one that was going horizontally, so I have 2 times my 2 plus x. Notice I use parentheses because the 2 plus x had 2 different terms, and I want to make sure the 2 gets multiplied by both of them. The same idea on the second chord. I have a length of 5, and I have a length of 5 minus x. I use parentheses again because the 5 minus x had 2 different terms. Well, your job, just like it will be on the test, is you have to solve for the x. The first step that I would have to do to solve for x is remove those parentheses, and to do that, we'll use the distributive property. That would now give us 4 plus 2x is equal to 25 minus 5x. Now, at this point, how you go about solving, there's a couple different ways that you can do it, and they're all correct. I'm just going to show you what I would have done to solve this question. What I personally like to do next is get all of the x's together. So I took the x from the right-hand side and I moved it to the left-hand side. To do that, to move the negative 5x, I added 5x. So 2x plus 5x gave me 7x. I collected the like terms, and the 4 was still over there on the left-hand side. So 4 plus 7x, and what's left on the right-hand side, just the 25. To continue getting x by itself, I'm going to get rid of the 4 next, so subtract 4 over. 25 minus 4 gave me 21, so 7x equals 21, and divide by 7, so x is equal to 3. Now, do you recognize, of course, you could check this answer. If you put your 3 back into the question, do you end up with the same product on both sides? Okay, so let's just quickly do that. If I put 3 right here, 2 plus 3 is 5. 2 times 5 is 10. So that means this product over here better equal 10 as well. If I put 3 right here, 5 minus 3 is 2, and 5 times 2 is 10. I notice that the 2 products are identical, therefore I know I have the correct answer for x. So that will cover questions 3 through 5 out of lesson 86. The next lesson that we talked about, this will cover questions 6 through 8, and I have them broken up into 2 different sections here. Questions 6 and 7 will be grouped together, and this was out of lesson 87, where we talked about our ratios between the perimeter and the area of our similar shapes or the corresponding pieces in our picture. So what is going to happen on the test is going to be almost the exact same setup that I'm showing you up here on the screen. I'm just going to use some different numbers. So I'm going to tell you that these 2 triangles are similar to each other. That's that little swirly mark that I have in between the 2 triangles. What did it mean that they were similar? They were the same shape, but they were 2 different sizes in the picture. Because they were similar, there was a ratio between the different side lengths, and that ratio will be presented to you just like it is up here on the screen. It says the ratio of their corresponding sides is 3 to 5. So on question 6, what I'm going to ask you to answer here is what is the ratio of the perimeters? Well, what was the theorem that we learned in lesson 87 about the relationship between the ratio of the side lengths and the ratio of the perimeters? It was the same. So because the ratio of the sides is 3 to 5, the ratio of the perimeters is also 3 to 5. Remember why that was the case? It was because the perimeter involved the side lengths. You just add up all the side lengths together. So the side lengths are used in the perimeter. That's why it was the exact same ratio that was presented to you. So now on question 7, I'm going to ask you for the ratio of their areas. Well, area wasn't the exact same ratio, but we did want to use the numbers that were given to us. What we had to do for the area ratio was square each of the numbers, because area is always presented in some unit squared. So meters squared, inches squared, whatever. So we had to square both of the numbers from the ratio. 3 squared would give me 9, and 5 squared is 25, and there's the final answer for the ratio that we would have on this question, 9 to 25. Now, the next question that we're going to walk through is going to appear on the test, and I don't think we saw one quite like this when we went through lesson 87, so make sure that you are listening very carefully as I'm explaining this question to you. It's the same rough setup that we saw before. We're just going to do one extra thing that I don't think we did during our lesson before. What I'm going to tell you is that I have two similar equilateral triangles, and I'm going to tell you their scale factor. So for this question, their scale factor is 3 to 4. Your job is going to be to find the perimeter of the larger triangle if you know that the smaller triangle has a side length of 12 inches. Let's just start back at the beginning and let's look at some things that we know already. What does it mean that triangles are similar? They're the same shape, but they're two different sizes. Now, there's a key word that shows up on this question, and you have to know what this word means, and it's the word equilateral. Well, that's a word that we've talked about already this year in geometry. Equilateral means all three of the sides are the same. So if I have one of the sides, that means I have all of the sides, and therefore I could find the perimeter of this question. Now, notice what the problem told us. It gave us the scale factor, so that's the relationship between the sides in this picture, and the scale factor is 3 to 4. It gave me as well a side length from the smaller triangle. So what I'm going to do first on this question is I'm going to find a side length from the bigger triangle. Then if I know the side lengths on the bigger triangle, then I can actually answer the question that's been given to us, which is the perimeter of our bigger triangle. Well, how do I find the side length of the bigger triangle? I'm going to set up our proportion. The one fraction that I'm going to use in our proportion is the given scale factor of 3 over 4. Now, as we looked at in lesson 87, we had to be super duper careful as to how we set up the second fraction. We had to be consistent. Look at your numbers 3 and 4. Well, clearly 3 is smaller than 4. So therefore 3 represents the smaller triangle and 4 represents the bigger triangle. The other piece that was given to us in this question was that the side of a smaller triangle was 12. So notice the 12 then went into the numerator because the smaller numbers are going into the numerator, and I'm going to put x in the denominator representing the side length of the bigger triangle. So I'm not finding the perimeter yet because the 12 didn't represent the perimeter of the smaller triangle, it just represented the side length of the smaller triangle. Just like we did in lesson 87, when fractions were equal, we cross multiply. So I have 3x is equal to 48. I'm going to divide by 3, and that gave me x was equal to 16. Again, that's not the final answer. The 16 is the length of each of the sides that we have in the big triangle. Now, here's where we got to remember that key word from the beginning of the question, that it was an equilateral triangle. Again, what did that mean? All three sides are the same. So in order to find the perimeter of the bigger triangle, I have 3 sides. They're all 16. So 3 times 16 tells me the bigger triangle has a perimeter of 48 inches. Okay, so again, what did I do? I found the length of one of the sides. Once I found the side length, then I could answer the perimeter of our question. We have one more thing that we're going to review today, and this was out of lesson 88, where we talked about our linear inequalities. On questions 9 and 10, what I'm going to have you do is simply just solve the linear inequality. What did that mean? To solve an inequality, you had to get the letter y by itself. So if you saw an inequality that looked like this one, the first step to get the y all by itself was to get rid of the negative 6x. Well, to do that, I'm going to add my 6x over. So I had 3y is less than, so the inequality sign was still there because all I'm doing was adding, is less than 6x minus 9. On the right-hand side, I wrote it in proper slope-intercept with the x part first and then the constant behind it. Those aren't like terms, so I can't put them together. One more step to get the y all by itself, I'm going to divide every single piece of our question by 3. Now notice we just divided by positive 3, so I could keep the inequality sign in the question, and when I divide, the final answer is y is less than 2x minus 3. One more question that just to review, how did we correctly solve with our linear inequalities? This one will require one extra step as we're solving here. So x minus 2y is greater than or equal to 5x plus 10. Well, again, to solve, what does that mean? We have to get the letter y by itself. The letter y is on the left-hand side of the question, so I need to get rid of anything else that's on the left-hand side. The first thing I'm going to get rid of is the x. Well, to move that x, because it's a positive x, I would subtract it over. Well, on the right-hand side, I already have a piece that contains the x. So 5x minus 1x gave me 4x. So on the right side, it now says 4x plus 10. The left-hand side, don't forget that minus sign stays with the 2y as you're moving it down to the next step. To continue to get y by itself, we're next going to get rid of the negative 2 that's right in front of it, so we would have to divide by negative 2. And hopefully already you're like, oh, I remember when I divide by a negative number, we had to reverse the inequality sign. The greater than that we had in the question is now going to be a less than. The equal to bar stays the same. So don't forget to do that on the test. If you divide by a negative number, reverse your inequality sign. Finish out with that arithmetic. So 4 divided by negative 2 gave me negative 2x, and our positive 10 divided by negative 2 was negative 5. Okay, so on questions, that was numbers 9 and 10, all that you're doing is solving. The other thing that you'll be doing from your lesson 88 is you're going to be graphing your linear inequalities. So let's finish up with these 2 examples, and then we'll review lesson 89 and our next time. Now, on both of these questions where you have the graph, these 3 questions, I already have the questions set up for you that the y is by itself. So you're not going to have to do any extra solving. You just need to graph it on your Cartesian plane. So if I were to look at this inequality, the first thing that I'm using when I'm graphing is the y-intercept. The y-intercept is negative 1, so I'm going down 1 space on the y-axis. The slope, what I see right in front of the x, is 2 over 3. So from the y-intercept, I went up 2 and right 3. Now, after I drew those 2 dots, we had to think about the kind of line that we were going to use. Was it a solid line or was it a dotted line? That decision was made based on the inequality symbol, whether it did or it did not have the equal to bar. This inequality does have the equal to bar, so I do want to draw a regular solid line. The last thing we had to decide was where we were going to shade. Again, that was based on the inequality sign for a greater than, meaning above, and less than, meaning below. The inequality sign that we have here is a less than, so where would I shade for less than my line? It would be below my line, so I would give a rough shade down in that area. Okay, so one more graphing question for today. Y is greater than 4x plus 2. Again, if I want to graph that, it's already set up for me. The y-intercept is used first, and that's positive 2. So I went up 2 on my y-axis. Now on this question, different than what we just did, the slope is not already a fraction. So you're going to have to make that slope a fraction. The slope is currently the number 4. The easiest way to make 4 into a fraction would say 4 over 1. So from my y-intercept, the rise is 4, so I went up 4, and the run is 1. I went to the right 1 space. Now that I have my dots, looking back at the inequality, I do not see the equal to bar, so I do not draw a regular line. I drew a dotted line in our question. The inequality symbol is our greater than. Greater than means to shade above, so I shaded above our line in our question. So our next review, we'll finish up with lesson 89. Then I think you guys will be ready to go for this test that you'll be taking for me next week.